Alright, so let's try this rule with an example. Here we have 2x minus 3 to the fourth power. This problem actually requires the use of the chain rule, however it is not the first step into tackling this problem. The first step would actually be the power rule, which we will not really get into, but I'll explain it briefly. We take the exponent and we bring it down as our base and subtract 1 from that exponent as our new exponent. In this scenario, we will be using 4 and we will bring it down as our base and we subtract 1 from 4, making 3 our new exponent. Now we are able to use the chain rule because we have the inside of the function unaccounted for, and the way we would go about doing this is that we would take the derivative of the inside of the function and multiply that to what we have so far from using the power rule. And from our background knowledge in calculus, we know that the derivative of 2x minus 3 is actually just 2, which we can just simplify and make it so that we're just multiplying by 2. And from here we can just finish it off by combining like terms. That would be 4 multiplied by 2, and that leaves us with 8 times 2x minus 3 to the third power, and that is our derivative and our final answer. Now let's try another problem with a trigonometric identity. Here we have sine of 3x squared minus 7. So sine does not have an exponent, so that means that we may jump ahead and start the problem with the chain rule. Using our background knowledge, we know that the derivative of sine is cosine, and we may not forget to respect the inside of the function, so we will multiply cosine of 3x squared minus 7 with the derivative of 3x squared minus 7. To take the derivative of 3x squared minus 7, it would require a quick use of the power rule, where we would take the exponent and multiply that by the base, which in this case would be 2 times 3, which is 6, and the exponent minus 1, which is 2 minus 1. We don't have to worry about that, leaving us with 6x. Since we cannot simplify any further, we can just leave it as cosine of 3 of x squared minus 7 times 6x, and that is our final answer. Alright, so let's just do one more problem to make sure we got this good. Here we have cosine of 8x minus tangent of 2x. Now, this problem is a little different because in this problem we were going to have to use multiple uses of the rule in order to accomplish it. So we will start by taking the derivative of the outside function, cosine, and since we know our trigonometric identities, we know that the derivative of cosine is negative sine, and we will keep the inside, which is 8x minus tangent of 2x. And as we've done before, we know that in order to use the chain rule, we have to have respect to the inside and multiply what we have so far by the derivative of the inside. This is where we will use the chain rule for the second time in this problem. Since we are taking the derivative of 8x minus tangent of 2x, we will implement the chain rule where there is a second composition of function, and that is the tangent of 2x. To take the derivative of 8x minus tangent of 2x, we'll start with 8x, and we know that the derivative of 8x is 8, and the derivative of tangent of x is secant squared x. Now, since we have the 2x inside the tangent of x as a composition function, we have to multiply with respect to the inside, which is multiplied by 2. Here we will just clean up our work to make it a little more formal, and we will be left with negative 2 sine of 8x minus tangent of 2x multiplied by 8 minus secant squared of 2x. And that is our final answer. Thank you for your time, and I hope you learned something.